Hello everyone, welcome to this lecture. Today we will learn how to create linked maps using the Earth Engine Python API on a Jupyter Notebook. So we'll be creating these four panels of maps using a satellite data. First one is, as you can see, a natural color, and the other ones are false color composite. I'll show you how you can create this four panel map using Earth Engine to create multiple true color and false color satellite image display on the Earth Engine Python API. So to get started, so you'll need to sign up for Earth Engine if you have not yet done so. And also we'll use Miniconda or Anaconda. You can download those using these links. And next, you need to create a Conda environment, a GE environment, and install Python and activate your environment in Conda. And after that, you would install the Earth Engine using GEmap using this code, pip install. And I've already installed it, so in your case, you need to activate this part. And I'll import the Earth Engine and GEmap libraries to access Earth Engine API, as well as do some visualization. And in your case, if it's the first time that you're using Earth Engine, you need to authenticate, and also you need to initialize using EE initialize to initialize Earth Engine API. And so next thing is to the main part of the code. As always, I would like to import countries database and subset to specific geographic region so that my analysis would be a more smaller size for example or demo purposes. And so in this case, I'll be using an example here, Uganda. And that's a small country in Africa. And so the next part is to import image, a satellite image. In this case, I'll be importing a Sentinel satellite image, and also I will filter it by timestamp. In this case, I'll be using image for year 2020. Starting from January to December of that year, so about 12 months of data. And I also need to use the filter bounds to subset it to my study region, in this case Uganda. So I'll provide that ROI, which I've already created earlier. And to convert the surface reflectance data, I'll just divide this by 10,000. That's a parameter that we have been provided as part of the metadata. So we'll be using that to convert the surface reflectance data into the proper data range. Okay, and I'll also calculate the median since it's a long time series data. I'll create one single image using this median aggregation or statistics. And that's it. That's my image. And now I have my image. And the next thing is, because I would be creating multiple visualization display here, what I would need to do is create different band combinations. Okay. So bands 432 is my visualization parameter for the first band combination. I'll also have another band combination which has band 8, 11, and 4. And the next one is, the first one is a true color composite. And this will look like this guy here, the natural color, as you'd call it, or true color composite. Mostly that's how we call it. And the other ones are false color composite, different band combinations which enhance different land surface. For example, this is a typical false color composite. You would see vegetation cover as red. and the other ones are, other options of the false color composite here. So what I'm creating here is different visualization parameter for all of the band combinations, for the true color as well as for all the false color composite. For example, here band 12, and 4. Sorry, this is band 11. I'm not sure why it is band 12 here. It should be a typo. Okay, and let me just fix that. Okay, save the script here. So yeah, and then we have created our visualization parameter. Okay, and the next thing is just the labels. So these are the labels, right? So you would have the labels over here, over here, over here. So let me create the labels here. So natural color band 4032. So I'll create a label here. This is how it shows up here. And the other combinations, this will most likely band 8, 11, 4, which enhances land and water. And this is a color infrared, usually another false color composite, and it's also band 12, 11, and 4, which enhances somehow vegetation. And the last thing is to combine all of this, like the image, the visual parameter, and also the label, and then we'll put them together here in this function. So gmap linked maps, you'll have your visualization parameter here, your visualization parameter, and also the labels, right? And the labels here, and also your image. You created an image here, and then you would input it here. EE objects, you'll put it here, your image. Okay, so now when you execute this code, you'll have something like this. All right, so let me just show you how you can. Let me uncheck here and then execute that so that it's cleaned. Right, again, I'll just return that, and then we have nothing here, right? So I'll go ahead and then run that from scratch, and it's busy, as you can see here. So when the execution is done, we should have all of this, labeling and the different false color composite in all of the 4 panels here. I'll click that to have a full image. I think, let me just zoom out a little bit so that we can see the full, linked maps. These are like split panels into 4 sections of the map. It's split into 4, 1, 2, 3, 4. And so yeah, so this is how you can see. As you can see here, this will the green will indicate more vegetated areas, and this is more like differentiating the land and water. This is a false color composite, and this is the true color composite. Mostly you would have some color combination that looks like a reality on the ground. When you look at trees, they are green, so you'll have something green looking on the satellite image as well. So the good thing about this linked maps is if you move one, the other one also moves, right? So they're not like split panel, like you don't have to drag. They'll just you can move one of the map, and because they are linked, you can look at what the other maps look like, and in different color combination. All right, so this is interesting. So that's how you implement linked maps in the Earth Engine Python API.